TI, you find the best fit parabola, and just so there's no consternation, I tell you which one to do. I'll tell you for max, use a line, and for Angry Birds, use a parabola. I mean, you can tell by looking at the data what it's going to be, but in case you panic, I know math anxiety is real, and I know it hits. I know that. So you could be looking right at the Angry Birds data and go, I gotta find a best fit line. It happens, and you know what the worst part is? The TI will do it for you. It'll give you a best fit line for parabolic data, and it'll give you a best fit parabola for linear data, and it'll do all those things. But you shouldn't do it. But I know how math anxiety is, so I've told you on both of them. And then once you have the best fit parabola, the way I do this one, I do ask you some questions on this one. I have to kind of finagle the results. Not finagle the results, I have to finagle the wording. I'm going to have you predict the way Angry Birds work, in case you don't know, and I explained it on the exam as well. There's these pigs. And you throw the birds using a catapult at the pigs, and the idea is to hit the pigs and knock the pigs over. So this image that I've got has 4 pigs on pedestals. The question is, which pig does the bird come closest to? If the pig, so what, basically you got a bunch of pigs over here, and you see the first part of the bird's flight, you will then continue the bird's flight using technology and figure out which pig the bird will come closest to if it continues to flight perfectly as it will. So again, extrapolate the data, trying to figure out what the end result is. Cool-ish? That's your exam.
And you'll have the data on there, but we'll
Data's on there. You have to enter it. You have to enter it and crunch it and get the best fit lines and or parabolas. But data's all on there. Data's all on there. Yeah. I'm trying to make this as user-friendly as I can, and I'm not making it tricky. No tricks. This is the exam, friends. I mean, this is the exam. No tricks. No tricks. This is what you can expect. Just familiarize yourself. Make sure, although I'm going to give you Pythagoras, somebody remind me to do that, by the way. I'll put that on the board on Thursday. I'll just forget to do it. You'll have the image you'll have this image on the exam proper. Just make sure you know what to do with it. Don't say to yourself, oh, cool, rules give me the formulas, give me the image, awesome, I don't have to study. Wrong, false. You do. You have to prep yourself by doing your homework, by going through that, making sure that you can do all this stuff. Yeah. I mean, you have essentially the same resources you have in your homework. You're going to have the formula on the board. You're going to have the diagram on. You're going to have the booklet in front of you with the steps for putting stuff in your TI. But that's like saying, I have the instruction manual for the car. I don't need to practice driving when I'm 16. Just give me the keys. False! Please, as a bike commuter, I know this is false. I've almost died too many times by 17-year-old. But anyway, go ahead, please.
I have 2 questions.
Yes.
You keep saying timed. Are we doing this the length of the class?
I've designed it to take about an hour. It might take more. I'm going to watch how people are doing. If we're down to 2 people taking the exam, everyone else is done, I'll ask the 2 folks to do is to go outside and finish, and we'll keep going.
Okay.
But I've designed it not to take the entire period. At least, again, on average. Speaking in terms of averages, it shouldn't. But if it does for 1 or 2 people, I kick them outside, we keep going.
Okay. So
First
secondly,
question, go ahead.
Second question, I think math is, can I have a page of notes?
A page? You're not going to need them. Everything you need is on the board or in the booklet.
Well, I like to have solved problems in front of me because it should, I don't know. No, if no, it's okay.
Well, the problem with that, here's my contention with that. In order to do that, I'm a huge believer in equal playing surfaces, equal playing fields.
Sure.
I'd have to give everybody essentially the exact same opportunity, which puts a level, this is my belief, and this is how I run my classes, which means I then have to proofread all those individual things. And I don't want this to be a regurgitation of something you've written down.
That's the only way I know how to do math.
No.
I'm just kidding.
Prepare to not regurgitate any more mathematics classes.
Okay.
You're in rules class now. No regurgitation. It's all about thinking.
Okay.
You are prepared for so much more than you think. You think you need to have that in front of you, which you don't. Here's a recommendation that I did this throughout my junior and senior years as an undergrad when I took my abstract algebra course. I was having a hell of a time in that course, understanding what the hell was going on. It was all proofs. It was like we were doing earlier today, but even more abstract. So what I ended up doing was just going back into the homework sets and doing problems multiple times until I could close my eyes and see exactly what you're talking about. I could close my eyes and see the problems in front of me. Now, I'm not saying that you should have to do that for this class, but I'm saying that's one way to get to kind of that level. Do a problem 1 more time. Even doing it 1 more time is better than not doing it at all. It's going to plant seeds in that long-term memory part of your brain that's going to help you with that remembering later down the road. So you don't have to do it ad nauseum like I did dozens of times until it became second nature, because that's almost like regurgitating. But what I learned from that was, when I could see certain problem solutions, I started seeing patterns like Chris did. Oh, 3, 5, 7. Oh, this is like that one I did in my homework. Oh yeah, it's just the only difference is here it's Max's weight, and in the homework it was whatever the homework was. So you don't need it. That's almost like a physical crutch that I'm gonna wean you off of. Trust me on this. Trust me on this. You don't need it. You don't need it. I promise you, you don't need it.
Okay.
I promise you. My exams are very user friendly. They are. I design them so that you look at them and hopefully you chuckle a little bit when you read them. Because the act of laughing at them a little bit will set your mind in the right place for taking it. As opposed to this that everybody feels when they go into a math exam. If I can make you laugh or make you just kind of smile a little bit during the exam, it's going to take that level of angst off and hopefully have you settle in and be able to actually perform very well. Like I know you can. I know you can. The level of statement and question you guys were doing today proves to me that you know you, and I know you can. I'm not worried about it. You guys can worry a little bit. That's totally fine. But don't get sick about it because you are well prepared for this. Assuming you've stayed current, you've done the homework, you've stayed caught up, you're prepared. You're prepared, but just preparing more between now and Thursday and do that. Okay? All right. Do you have any previous, we have time. I don't want to go on the new stuff. Do you want to look back to linear modeling and look at anything in there? Do you want to pull something else from quadratic modeling? What are we thinking? What are we thinking? Please.
Oh, you may have already done. You didn't do E5 on linear modeling homework?
I may not have. Want to do that one?
I didn't.
Let's take a look
Is
at
that
it.
okay? Yeah.
No, absolutely. Let's take some time. Let's go over some
I
other
just need an
problems.
example. I just want to go.
No. Rather than going into new stuff right now, which we can wait till Thursday or Tuesday, whatever time, I'd rather look back and wrap up some stuff. All right, so here's quadratic modeling. There's the book. Don't need that right now. Let's back out linear modeling. All right, E5. E5. Let's think back to the examples. We started in class. Fantastic. Great. This is great. This is a fantastic one to revisit. Fantastic one to revisit. All right, let me clear some board space. Let's put ourselves at peace here. What's grade defined as? Remember what grade was defined as, friends? Yep. That's all. It's slope. It's rise over run. It's rise over run. It's rise over run. It's right. It's just it usually does a percentage, so it's a decimal that you can convert to a percentage. Okay, so if a road rises 200 feet over 2 miles of run, what is this grade? Oh, hell, there's the answer right there. Or slope. Look at me, overkilling. What do you think? If it rises 200 feet over 2 miles of run, what do you think its grade is? Ben, help me out.
First of all, we have to change feet to miles.
Don't ever forget that.
You have to change feet.
Rise usually is not in miles, but run usually is, especially when we're talking about roads. Roads aren't that steep on average. They're not that steep on average. 6%, 7%, 10% on College Way. They're not insane. So when you see 200 over 2, that might be very tempting to say it's 200 feet over 2 and call it 200 over 2 and call it 100. But that's 10,000%. That doesn't make any sense. What the hell is that? I don't even know what the hell that is. So it's 200 feet, yes, over 2 miles. And this is where your second project will come in really handy. This isn't making sense right now. You got to do a conversion. Either change 200 feet to miles or change 2 miles to feet. What do you guys think? What do you want to do? Say that again. How many feet are in a mile? 5,280. Right? 5,280, stupid number, but yeah, exactly, stupid number. So we got, this is really 200 feet over 2 times 5,280 feet. Let me see if I can do this in my head. 200 feet over 4, that's a 10, 5, 6, 0. Did I do that right? Is that right? Check me. We're checked. Thank you, friends. This I know I can't do it with any kind of accuracy. I get 20 over, somebody just give me the decimal if you don't mind, so I don't have to, I can approximate it, but I'd rather get down to like a 0.0189. Wickedly impressed. I can't do any precision with arithmetic in my head. So what approximately is the grade? I'm hearing about 2%? I love that. About 2%? I love that. At 1.9%, 2%? Round it up. I'll tell you what to round to. Don't worry about that. So about 2%. About a 2% grade, which is actually a fairly normal road grade. That's a fairly normal road grade. I mean, that's not one that would beat you up if you're on a bike or running. But you feel the hill. You feel the hill. It would be kind of like Newport between College Way and, say, Mount Washington. In places, that's about 2%. On average, it's a little steeper, but generally it's 2%. Right around Northwest Crossing, it's about 2% in there. Cool?
Thank you.
Make sure you buy what just happened. Let me see hands if you don't. Oh, okay. Sorry, that was too many questions at once. I'm going to say, but no, wait. I'm not. Fair enough? Please, Kurt, go.
Just out of curiosity, if we have to convert, are you going to provide us with?
It already is. Pilot Butte, I have a conversion on there for you. Yep, I already, because I know that's very easy to forget. It's very easy to go 200 divided by 2 is 100. As Americans, we suck at unit conversions. We suck at unit, we suck at it. As Americans, we're terrible at it, which is why your entire second project is devoted to just that. The second project is entirely unit conversions, and you'll never make a mistake like dividing feet by miles and calling it meaningful again. You never will. Because you know what else we suck at as Americans? We also suck at realizing that 10,000% grade doesn't make any sense. Like people will go, 200 divided by 2 is 100. 100 is changed to a percent, put 2 zeros on it, 100%. It doesn't make any sense. But as Americans, we suck at checking ourselves. Please, Ben, go ahead.
Will you put the number of feet in the mile in the test?
It is. It's already there for you. Yep, absolutely, absolutely. Anything else? Anything else give you grief? Well, that's right. That's why I want to kind of look at these questions to make sure that you guys can make peace with them here.
In the quiz where you say, in this last quiz on Quadratic regression, you say you want 2 pers, in those quotation marks, you're talking 2 y's, is that correct?
No, the per is a unit. Because it's a per, probably per year, and I think it's per 100,000 people. So you need a per 100,000 for 1 per, and then it's per year, or per, there's a rate of change going on too. Yeah, so 2 pers, that's what I mean. Not a Y value, just a rate. So in other words, this grade of this is 2% because it rises 2 feet per 100 feet of rise. But the second per is just how the unit is set up in that quiz. The way they give you those rates is in something per 100,000. So you would have to have,
so many deaths per year.
Right, so many deaths per year
and so many
per something else. Exactly. Right, so many deaths per 100,000 per year.
Gotcha.
Yeah.
So that's the way I did that.
Anything else?
Took a while to figure it out.
Give us grief. Let's scroll down. It's okay here? E6 okay? Grade 3.4% rises 15. How much does it run?
Let's do it.
Yes? Okay. I'm seeing lots of like pseudo-terrified looks. Pseudo. It's hard to read. Okay, let's do it. So, slide this up. Let's clear some space. All right. Has a grade of 3.4%, rises 1,500, how much does it run? Related to E5. Related to E5 for sure. Related to, I had the camera pointed at the wrong place that entire time. E5. Those of you playing the home game, press pause now. Okay. Back to E6. Yeah. So, it's related because it's still great. It's related because it's still great. The difference is what you know and what you don't know. You now know the grade. E5 was asking you for the grade. Here you know it's 3.4%. So you're still going to start using this relationship of what grade is. It's just that you know 2 pieces that are different than the 2 pieces you knew in E5. So do you know grade this time? Do you know rise this time? Do you know run this time? There's a difference. So in E6, you know the grade is 0.034. You know the hill rise is 1,500 feet, but you don't know how much it runs. Your job, figure it out. That's basically your job. Ben, go ahead. Can I say it a different way? 1,500 divided by 0.034. There's a difference, because it's not commutative. So basically, we have to get this guy out of the denominator and on one side by itself. With E5, it was a piece of cake, because what we didn't have was already by itself on one side. What we knew was in this fraction right here. It would be really sweet if we could turn this into something that involved this and this in a fraction and had that by itself, and we can. The trick is remembering the mathematics to do it. Okay, this is where we have to kind of think back to our previous math classes. I want to get run out of the bottom. Should I call it x? Would that make it easier if I called it x?
Yeah.
Yeah, I heard a yes and a no. That means on average I'm confused. Yeah, we'll go with x. Call it x. Raise hands, vote. Call the run x so we can use it as a variable. 1, 2, 3, 4, 5, 6, 7, 8. Leave it as run because it's a word. The x's slightly have it.
I think that's half and half.
Well, it was about 3 less. About 3 less. Solve for x. How? What should we do? Janelle, help me out.
Times x on that side and then divide that. Or you times it on that side and divide it on.
I can't do different things to both sides of the equation, can I?
Sorry, you have to times it on both sides and that cancels it out on that side. And
Oh, I see what you're doing. You're doing 2 steps at once. Good for you, my friend. Awesome, awesome. Great algebra skills. So Janelle is saying is multiply the whole equation by x, essentially, or both sides by x. So multiply this side by x, multiply this side by x. What that will do on the right-hand side is it undoes the division by x. So that cancels, and you're left with just 1,500 feet, I guess. On this side, you're then going to have 0.034x. And we're damn close. I want to solve for x, though. So, Janelle, what was your step 2?
okay, so step 2 is that you would do the same thing for 0.034.
Except instead of multiplying.
And instead of multiplying, you're dividing.
Yes, ma'am. Perfect. 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 Because that'll undo the 0.034 on the left side, and you're left with x equals 1,500 feet divided by the constant of 0.034, which means my final unit will be in feet, and that's where I want it to be. I want it to be in feet. So what's that end up being, friends?
44,000.
That makes, I was going to say,
There we go.
we're missing a 0 there.
44,117 point about 65.
I'm going to call that 118 feet.
Okay.
If that's okay.
Oh, yeah.
It doesn't make a whole lot of sense to get too precise with the answer. Some folks will actually argue we should just call it 44,000 feet and throw away the 118. I'm okay with that too, due to something called significant figures, which some of you may not have learned about, and it's okay. So I'll tell you what to round to, basically, in general. So I'll say round to the nearest foot. Boom, there we are. Ben, your question, or your comment, go ahead.
Can we multiply both sides by 1 divided by 1,500?
You sure can. You sure can. Ben's question is, instead of doing it this way, which is perfect, that way's perfect too in a different way. Here's solution method A. Solution method B would be multiplying both sides by 1 over 1,500. So on this side, you're going to have 0.003, oh, excuse me, one too many zeros. 3.4% equals 1,500 over x times 1 over 1,500. And Ben, what's the benefit of doing that on this side?
Cancel the
So what you're going to have on this side is 0.034 over 1,500 feet. What's on this side? Careful.
one.
Getting closer.
1x.
Not 1x. 1 over x. So now what do you have to do? Well, then, yeah, you cross multiply, Tiff. Is anybody dealt with proportions enough you can just flip both sides? That's legal too at this point, if you're comfortable with proportions enough. But you see, what you're solving for right now is 1 over x, the reciprocal of x. Notice how it's upside down from this? This is 1,500 over 3.4%. That's 3.4% of 1,500. They're reciprocals of each other. So if you do it that way, Ben, just remember to invert your result to get the reciprocal of it, because you need the reciprocal of that value. Is that fair? That's why when you earlier said, what's 0.034 divided by 1,500, I said, careful, they're not commutative. They're not the same thing, they're reciprocals. Fair? Great point. Totally possible for the solution as well. Just make sure you know, this is where algebra can get a hang up for us. This is where the algebra skills that we learned and may have forgotten some of from previous can get in our way as opposed to helping us with the solution. Yeah? Ish? How far did you travel on the road? If you do, 1,500 feet of rise and 44,000 feet of run. This is E7. If you were to hike and make up that kind of height over that kind of run, how could you figure out how far you actually hiked? And the answer is neither 44,118 feet, nor is it 1,500 feet. You got to use Pythagoras, don't you? Because think about why. Here's the hill, drawn horribly not to scale. Here's you, hiking, taking a big step because it's this big hill. And you're smiling because you're not doing math. You've picked up 1,500 feet of rise over 44,118 feet of run. Neither of those answers the question how far you hiked. This is how far you hiked. So in order to figure out how far you hiked, you have to use Pythagoras to figure out the hypotenuse of this triangle. That's the right angle here. I mean, by definition of rise and run. So that's where that formula I'll have on the board will come in handy. I'll have hypotenuse squared equals rise squared plus run squared. So your job is to backfill what you need. So you backfill the rise, which was 1,500 feet. You backfill the run, which was 44,118 feet. Let me turn this screen off if that's it in the way. There we go. That's the hypotenuse squared. That's the square root of the hypotenuse. We crunch those numbers together. I can't do that in my head. I'm sorry. 750,000 square feet and then something else over there that I definitely can't do in my head. So what do we end up with a hypotenuse squared of? What's this guy? Don't worry about the feet notation. It's just 1,500 squared plus 44,118 squared. That's all I'm looking for. I wonder if you can see this. Practicing later. Not quite. What do we got?
All right, I got a number, bro.
Help me! I can't do this math in my head.
2,338,236.
I love it.
Okay.
And that's actually, yes, we getting this? Yes? No?
No.
Ish? I don't know. I'm hearing some dissension.
Yeah, no, but I raised it. I got two.
Do they have to be in front?
No, not at all. Not at all. That's perfect. Squared. Yep, go ahead. We get a slightly different number. I got one, what is that? That's going to be 1.9 billion square feet we were getting here. So, we're getting...
A little off.
That's okay.
You wanted a number.
Well, then you gave me a number.
You never said it was right.
You sound like a politician, Chris. You wanted a number.
That's what I got.
$3 trillion. There you go. There's your number. That's square feet. That's feet squared. So the problem is, that's square feet. That doesn't tell us how far we walked. So this is the hypotenuse squared. Your job is then to take the square root of that to figure out what the hypotenuse actually is.
Which is 44,143.5.
Say that again, my friend.
44,143.5.
We'll call that 44,144 feet.
3,000.
Notice how it's a little bit more than the run? It should be. It should be. This is not drawn to scale at all. This is a much skinnier, much shallower triangle than I've drawn it to be. So that's how many feet you hike. Divide by 5,280 if you wouldn't mind, Maddie. 8.3 miles. In case that's a lot of feet. It's easier to talk about miles sometimes. So there you go. There's question like number 2 on your exam, like answered way over answered, which is fan-freaking-tastic. Cool? Let the wonderment wash over you. This stuff is great. This stuff is great. You just have to let yourself believe how cool this is. And maybe you won't. Maybe you're to that point, that's okay too. It's totally fine. I don't understand Justin Bieber, but a lot of people understand him. I think he's great. Twerp. Yeah, I'm talking to you, buddy. So, but anyway. I guess the point is, I don't want you to fear what's happening on Thursday. I don't want you to fear that exam Thursday. You're going to do just fine. Just prep. Go back, practice, look over some stuff. We'll kick you out of here a couple minutes early so you go back and look at it again. Yes, just don't fear it. Try not to come. I know you got math anxiety, math agita, as my grandmother would say, grandmother Mary would say. But try to kind of swallow that back and realize it's not a tricky exam. I'm not out there to trick you. That's why I try to tell you exactly what's going to be on it. Sort of giving you the examples themselves. If you want, go play Angry Birds, take some screen captures, try to model it. There's good practice right there. Play Angry Birds. So, okay, doke. I will catch you guys on Thursday. You too, Bieber.
Yeah.